When you save stuff out to file, in text file land, you never actually think about this distinction. But in files, it's sort of a serialized format, or sometimes what I call like a cold data structure. It is laid out in such a way that it means the right thing, even if you copy paste it somewhere else. Like the sequence of symbols in the blob is all you need to reconstruct the meaning. So main is your entry point, that's where your program starts, but that's actually a lie. It's always been a lie. There's always been a real startup point that calls main. And that real startup point is what initializes stuff like malloc, right? That makes it so that the C runtime is ready to go. Where do you find someone who's just doing the plain boring research of like, practically speaking, how do we get a debugger that looks like Visual Studio on Linux? Why isn't that? Is there a reason why that's not happening? Is it just a development bottleneck?
Can we start talking a little bit about how did you get into programming in general? What did you learn from?
Yeah, well, It happened fairly young for me because I was fascinated by the idea of making games. So I don't remember exactly where it started, because I remember I tried like random stuff you could find on the internet, like Visual Studio, but not like Visual Studio C++ or C# is like basic, I think. I don't even remember what I was doing because I didn't really understand. But like I would learn how to program like little forums and stuff. So somehow that helped. And then eventually I found GameMaker. And so I learned a lot of programming through like drag and drop and then GameMaker scripting. And so that was like when I was 10, we could say, when I was exploring at that level, just like trying stuff out until GameMaker kind of stuck. And so yeah, it was about making games and trying things out. And the drive to go farther and farther just came from like realizing I need to know more of this to do better with my games, until it kind of became the case that the programming was at least as much fun as the game stuff. Although the older I've gotten, the more I'm like, there's a lot of fun in game design too. So like I do miss that part, and have enjoyed going like all in on like tools and programming technology. And then I'm like, but there's some fun to making games that I've been missing too. So, that's kind of the trajectory I'm on is.
What kind of games did you do when you were experimenting with GameMaker?
Oh man, I did. So some of the ones I did, like a lot of my games were like small, like just let me try out a thing. So like a version of Tetris where the pieces are magnetized, so if they're the same polarity, they'll like repel and won't land on each other and stuff. And I'm trying to see. There was a few times I worked on like cool little like platformers and stuff, like action, like what's the word for it? Well, game is all about twitch reflexes, just trying to like make a cool, difficult sort of Meat Boy clone kind of thing. Just stuff, yeah, all kinds of stuff though. I think that I loved games of all sorts of genres and wanted to find something that I was good at making, and so there was all sorts of stuff that I was interested in trying at that point. Yeah.
When you said you started young,
yeah,
what age were you when you started?
Well, I think that around, for GameMaker in particular, I was like 10 or 11-ish, like when I discovered it, and started getting really into it. And yeah, I think it's hard to say for sure that I hadn't, like it came naturally, but I feel like I must have been doing something else before that. So it's really hard to know, because I had so much interest in like, just because I had been playing with the Visual Basic stuff. I tried several things. I think it's really hard for me to pin down the origin story because of how young I was when it started. But like 10, think of like 10-ish is when I knew for sure I was into making games. Yeah.
It's young. When you were starting to gravitate towards the more technical things and like quote unquote serious programming, where did you learn from?
Okay, yeah. So at first it helped that GameMaker had a really nice community to hang out in, and so most of them were programming in GameMaker, but some of the GameMaker had the transition path here was that the better you got at GameMaker, the more you learned about GameMaker customizations and like plugins and extensions, and those could be coded in anything that you could compile to a DLL. And so there were some people around who would explain how to do C++ DLLs to make GameMaker like plug-in expansions to the system. And so I think I just like hanging out with those people a little bit and like looking at how they were trying to do expansion. None of us, I think we were all within a few years. So like none of us really knew what we were doing, but we were all figuring it out together. And there were a few people like 5 years down the road from me in figuring it out who just kind of like showed me what they were up to. And so, yeah, it was very much like that. There weren't like resources or anything. At some point I did like start reading C++ books, and I learned the language well from that. Like reading Bjarne Stroustrup stuff will help you understand like, oh, this is why C++ is like this, and this actually works in this particular way. Like that's all helpful to know, but that wasn't really how to program so much as just background knowledge about C++. So I think that is more like the people around the community that I was learning from, like how you actually do stuff.
This was already when the internet was around, right?
Yeah.
So
Yeah.
have you found any sort of usefulness from getting the knowledge from in the internet, or not really?
I think definitely. I think that I didn't really have anyone like I'm not someone who had like a parent who was already programming. I don't think I knew anybody who was into programming.
Yeah.
And so even the adults in my life would be like, you want to make games? I actually don't know how that's done, but that's cool and good luck. And so, yeah, having the internet exist was critical to me being able to get started so early.
Okay. At some point, you started Mr. Forth,
Yeah.
like of a brand.
Yeah.
Can you tell me first a little bit about the name?
Yeah.
And then what was it?
Yeah. So that also dates back because it's basically an evolution of the internet screen name I was using when I was a little kid. So when I joined the Game Maker community for the first time, I was like, what's my screen name going to be? And I was, for whatever reason, really fascinated by the concept of like four-dimensional geometry at the time, like higher level geometry. I had just been exposed to it maybe within a few months, and I was like, this is so cool. So my screen name is going to be Fourth Dimension. And then I got a little older, and so I made it Mr. Fourth Dimension when I made a screen name for Twitch. And then at some point I just was like, okay, I'm just gonna call it Mr. Fourth to shorten it. Okay. And so that became like the thing I can go, because there's also like, I misspelled dimension when I was 10 with a T instead of an S. So it's like, let's just drop the dimension from the screen name since that part is really confusing. And we'll go with Mr. Fourth as the nice, easy to remember name.
Okay. When did the screen nickname became a brand?
Yeah, that's very recent. So a couple years ago, became independent. I was working at Epic up until end of 2023. And so at the beginning of 2024, I was like, I've been thinking for a long time about a bunch of projects I want to do, and I have some savings to invest into trying to complete at least one of my project ideas. And one of the big things that I've always wanted to do, like I've always been drawn to content creation, like I don't know why, but not when I was 10, but in like 10th grade or 12th grade or somewhere in there. So I was more like 16 at this point. I started making like C++ tutorials because I was just like so interested in the idea of taking everything I was learning and turning it into YouTube content. And I don't know why, because I've never really enjoyed the video production part of that at all. Like it's actually most of the work goes into video production, and I constantly wonder why I am so drawn to it when I actually hate the day-to-day activity. But I like the planning of it, and it feels like a useful way to re-express what I'm thinking about. And so I forget what the question was, but yeah,
I was asking about the Mr. Forth brand as it is, yeah. But I would actually linger on this a little bit, like this content creations for if you're making a tutorial or like something. First of all, you need to clean up what you know about this in your head. Mm-hmm. So you have to have this sort of structured, and then think about how to lay this out for anybody who will come over and try to learn this. Like there's a lot of activities involved besides the video editing part, and also like the joy of sharing it with other people. So I think there's lots of things that are positive there that could draw you in.
Yeah.
But maybe we can do it more chronologically and talk first a little bit about your professional experience, because I had the idea that the Mr. Forth kind of brand started way back when the 4coder and everything like that. So maybe you can walk me more like chronologically.
So how about we figure out how I got to 4coder, and then what Mr. Forth only started recently. So like the in between steps from 4coder to there. Sure. So I was going to college, which was when I started 4coder. Like 4coder started because Handmade Hero came out in 2014, and I was watching that from the beginning. And I was also in college and like wanted to start practicing programming in the way that I was seeing on Handmade Hero. And so I did a couple of very small things. Like I put together a little command line game. Was the first thing I ever programmed, where I was like, there will be no classes, there will be nothing but C code, and I'll see how it goes. But it's just a little command line, just a little text adventure kind of game. And that was my first one. And then I think within a couple of weeks of that, Casey on the Handmade Hero stream mentioned that he was like, yeah, I use Emacs. It kind of is sad that it's so old and difficult to explain how it works, and it doesn't really do anything fancy like modern code intelligence kinds of stuff for me. And it would be really cool if the editor understood the structure of my code and helped me at a higher level of abstraction than just manipulating the character sequences. And so I was like, that's a cool idea. Maybe that'll be the next thing I work on. And so I took up the idea of 4coder was to explore everything that Casey complained about, in that, like, here's how I use Emacs and the things that I wish it had, like mini stream that he had done. So that was where 4coder started. This was before I was doing MrForth.com. That wasn't a thing yet. But I was already Mr. Forth Dimension on Twitch at this point, right?
So that's why this was 4coder.
Yeah.
The 4 was
the 4. Yeah, the 4 was kind of a brand at that point already. It was also, I liked the idea that, because the spirit of it was that it's not just for editing text, it's for coding. It's like it knows that it's for code, and it will leverage that context. So it's for a coder. Like, that part makes sense too, but I get to stick the number 4 on it so that the
that's meta.
Correlation works. Yeah.
Two narratives that you can. Okay. Nice. Then you started work on 4coder, which is an Emacs.
Yeah.
How do you call it? Distribution? Like.
Yeah. Well, I wouldn't say, it was definitely like it was a ground up text editor in C, entirely inspired by the architecture of Emacs, at least the architecture you see from the outside as a user. Later on, I think I read some Emacs code, and I didn't fully understand like Lisp, so I didn't understand eLisp, and there was a lot of stuff about it I just didn't know how to fully get my head around what it was doing, which was a part of the point. It was like, I don't really know how to customize in Emacs because I've only really ever been practicing C and C++ and maybe some stuff, but not Lisp and not eLisp. Like, this is weird. So one of the ideas was fairly early on, like, if there's going to be customizations, because, I started working on it, and very early on, Casey and a few other people in the community were like, I would like to use your editor when you think it's ready, and you should start distributing demos now. And after one demo, then came out, then the next thing I heard from people was like, if I could just customize the key bindings, I could start using this probably today. And I'm like, oh, okay, so customize key bindings. Well, what's the easiest way I know how to customize something? Think back to GameMaker. How do you make plugins to GameMaker? You make a DLL. I'll do the same. That way I can code it the way I already know how. I don't need to learn a new language. I'll just use the language I know. I'll make the extensions in the way that I saw GameMaker make extensions. So it just sort of was the combination of things I already knew how to do, was to make a C++ customization layer on top of the editor I was working on so that people could do their rebindings. And later on, that grew into what 4coder became, which was not at all about the code intelligence I had originally looked for. Like, there was one little bit of code intelligence that made it into the final version, but it turned out that there's a lot of interesting reasons why you can't just do that you can't just automatically do that. There's a lot of other stuff that an 18-year-old who's still, like, even though I started early, I think sometimes you need to be a full-grown adult to, like, learn how you make a compiler or something, right? So there's just a lot of stuff I didn't know about what I was doing. And so it's just like, that was never going to happen, especially not for C++. But what could happen was I could really go all in on making this customization layer powerful. And that turned out to be the reason a lot of people liked it, was because you could do anything you wanted in the customization layer to make your own editor. So it kind of became more like a game engine for programming your own text editor. More so, it's not a game engine, but it's that level of customizability, right? You've got a core that you're going to just reuse, and then you've got just full power to build on top and rearrange things.
So zooming in on the extension system, I'm assuming this works. You have your core, and it can call into a DLL that somebody can provide. And there is somewhere an API that you learn from, like a reference documentation. Yeah. What can you provide as a function that after you compile it into a library and ship it, the core will load into it, right?
Yeah. Yeah. So I'm going to see how much of this I can still remember. The basic idea is that 4coder is built out of like a mainframe loop. Every frame you're going to do some work and then render it, and a bunch of commands. And so during the frame loop, there are hooks like we're doing rendering now, and there's a hook that's just like, how do you want to draw each view? So in the core, there are ideas like we're going to have split like panels, split the screen up into panels, and in that panel tree, each leaf of the tree sort of is a space on the screen, which we can then put a buffer view into. And so there's this concept of a view, which is not a panel, but it's one of the leaves of the panel tree paired with a buffer that you are viewing. And that makes a view. And then there are hooks attached to those. And then there are hooks attached to the buffers. So like on load or on save and close. Like there are a couple of hooks you can assign to different main things. And then everything else is just a command, which is like no parameters besides the whole context of the program. And it figures out based on the currently selected view and the positions of the cursor and anything else, like all the state plus whatever, all of the state, and then you hit a single key. There's like a key binding. Like the starting point of all this was key remapping. So the core idea was everything you can do is assigned to some kind of command, or is a command, and that's bound to a key or to a mouse click or something. And so most of the plugin work, like when you're making a customization in 4coder, a lot of what you're doing is just deciding what your commands are going to be and how they map onto the keys. And then the other big thing you're doing is like hooking and replacing the buffer render so that you can add more information onto the screen visually, right? Those are the two main things. There's little things like, I want to like have more logic about when I treat something as plain text versus when I parse it and give it syntax highlighting, and like lots of minutia stuff that crops up. But that's all built on top of hooks and commands at some level.
Nice. This is such a cool thing to build a fundamental layer that would be so extensible that you can build everything on top, and then you can give it to somebody, and like somebody else can replace the thing on top and repurpose it into their own thing. Yeah, that's awesome. Yeah. So after you made it, Casey Muratori, I know also Ryan Fleury for some time have been using it. How was the reception of 4coder in the community?
I think a lot of people don't care for it, and that's just because it's not Vim, it's not it's not like the best editor ever. In fact, I think I have been pretty vocal about the fact, like, I like it, it's perfect for me, but if you're not eager to switch already, then I'm not going to try to push you on it. Now, I know there's also like the community there is a core community that loves it, and so I've actually stopped using 4coder, and the people who do use it have taken up maintaining it into the future with an open source community fork of the version that I had when I said I was done. So that's cool. Like, there's definitely people who are relying on it and building on, not just building new custom layers, but iterating on the core even, and cleaning up little issues that were still lingering when I wrapped up my involvement with day-to-day work on it. So I would say it's for the people who like it, it's exactly what they want, and for everybody else, it's hard to imagine switching to it,
Okay. So you've been developing this for a while. At some point you released it, and then you sort of maintained it over a period of time, and after which you said, okay, I'm done with it. Yeah. I will open source a current version.
Yeah.
I will keep version for myself that I can do and edit. When you look back on this journey with 4coder, how do you view this? Like, are there some lessons that you have also got from not only technical, but also like, project management style?
Yeah. Lessons. I think it's a little hard to draw lessons because a little bit of what happened was getting lucky. Like the timing, I was the first person to get a good editor ready to go in response to what Casey was doing, which meant that everyone saw mine first. So like that's a bit of luck, I think. But I think the biggest things that I've learned in terms of project stuff, it's like half technical and half project. Like there are things that I learned that are like, oh, actually, this is a technical problem and I didn't know it would be a technical problem. But like the amount of work that it takes for a single person to document the entirety of a customization layer, like what are all these hooks, what are all the commands, like or what are all the functions you can call from the commands and the hooks, and also just like what are all the helpers. Like you end up in a situation where even if you have a base layer, you don't want your abstraction layer to have every little thing you ever want, because that means that all the bugs in all the little helpers are on the wrong side of the divide for the users, right? You want as much as possible that they're seeing all of the code. The only reason not to show 100% of the code is because you're making money off of it, which is what I was doing at the time. So like the things that were in the core were just like the most bare essential. Like here's the buffer manipulation architecture, here's panels, some memory management helpers and ID management and stuff, fonts, like a couple of the things you just don't like. The reason you don't make a text editor yourself is because there's all this work. It's like I'm gonna try to do all the work and hopefully get as close as possible to you can start from the design you have in your head. That can be where you start. Now it's not that easy because it turns out that even if you do a pretty good job, you always build some of your assumptions into these sorts of systems. So it turns out to be a lot harder to get a Vim style thing working on 4coder than an Emacs style thing. Go figure. But I would say the big thing I learned is that shipping a real product like 4coder isn't just about the programming of the core, but it's like there's a lot of like, how do you set up a website? How do you set up the documentation? How do you maintain all that documentation? How do you give example code? All of that stuff is more important than I had understood, but more maybe bigger than that. It also requires some kind of smarts in the technical decisions that you make to get there. So like to document it, I tried so many different things because it wasn't that I didn't have one working, but every time I got one working, it turned out to be really cumbersome to maintain. I want the documentation, like if you just like could have magic, what you would want is that you have all these functions that are in the core and they're implemented there, but they need to be marked up so they have hidden away behind the text file that explains the code. There's like metadata attached to the function somehow, and that metadata is the documentation. Now, obviously, most people like stick it in the comments and then do a pre-parse, and so I did all kinds of things in 4coder where I was pre-parsing 4coder's own code. That was necessary in the custom layer 2 for the command system. Like there's stuff that goes on where you want like a command needs a documentation string too, so that when you're new to 4coder, you can look through the commands that are available, and in 4coder it can give you a description of like what it means to do this command. But if that's customizable, how does all of that data get into, like, how do I make a customization with a command that also has the metadata, right? That's one layer of the problem. But then the core has a separate one. And so over and over again, I hit these issues where I was like, didn't realize how many slightly redundant systems I was going to need because of this split between core and custom. And everything's a little different when it's an API. Commands are a no parameter function that returns nothing, but many of the APIs or functions that you need in the API layer aren't that. So they aren't actually commands. The command markup system doesn't work for them. You need to mark up return and parameter documentation. So it needed a different system. And I built probably 2 or 3 of those. In the last couple iterations on 4coder, a lot of the stuff I was working on was like, wait, how do I make the documentation live near the function and then get packaged up into a data table that I can read from at runtime? And also, how do I take that same data and send it to HTML for like a website version of the same information? And so that's not non-technical, but it's not the mission that I had with 4coder. It was other technical skills I had never developed that needed to get done to make it a finished product. And that kind of stuff, I think, buried me back then. I didn't have a good discipline of like, I'm going to need to get organized and figure out how you do this without making it heavyweight. And so I tried a lot of stuff. It was all heavyweight and felt bad, but I learned from that I needed to get better about thinking about how I'm going to manage data and organize these sort of things that aren't the core mission, but that are just bulk work that goes along with a product, you know?
I can see how at some point you were like, okay, I'm done with the project.
Yeah.
Because if you have the development and you have the like public / documentation / this kind of product side of things to maintain, and ideally after some point for every technical person, like the editor is done. So it's less sexy to work on, to continue improving compared to something new, right?
Yeah.
So at some point it's like, okay, I really want to get away from this.
Yeah.
How long have you been like maintaining after you released the first version?
So I mean, I don't know exactly the first time a 4coder version came out, but from the day I started it, which was sort of like December 2014, like I was saying, that was when Handmade Hero started. It was very shortly after, maybe January 2015, somewhere very early in that period of Handmade Hero. I started it, and I kept working on it until, I want to say, the end of 2020, beginning of 2021. I think that the open source version came out in 2021. So I was probably working on it for 5 or 6 years. Although that was with varying amounts of daily attention. Sometimes that was full time, but most of the time that was spare time. And then there were periods of time where I wasn't touching it for months because other stuff was just going on. So yeah, it was about 5 years though. And interestingly, that's like the time span that has happened to me on most of the projects. Like there was one big game that, if we were to rewind the clock back to Game Maker days, there was one big game project that I was doing with a few people from that Game Maker community. And we tried for about 5 years. And this was an overly ambitious project. So we had many iterations of starting from scratch with it. But
was it MMORPG?
Yeah, it was actually. It was that and also a physics game at the same time, so that It was as hard as possible. Yeah. But I think that was useful to do that kind of thing because I learned a lot. And in about 5 years, I was like, I think I'm done trying this. And I think the same thing happened with 4coder, except I made some progress in the 5 years. Like I actually got somewhere good. And so that's kind of been my pattern, my rhythm personally, is I can maintain interest in one thing for about 5 years, but at about the 5 year point, I desperately need to start over on something, a new idea.
I mean, on the topic of like 4coder, you made it, like, and then like it was there. So when you make a MMORPG and like 5 years down the line, you realize it's getting nowhere, and you drop it. You can consider this like a failure, but right, like you have some sort of learnings and lessons, but like you didn't ship, so like there's nothing. But in this case, like there is an editor. It's already there for a number of years, so that's like quite a success. On the technical side, if you remember, what were the difficulties in the 4coder development in general? Like what were the bottlenecks of the program?
Well, I think the biggest thing was that early on the thought was that it was going to do all this code intelligence stuff. And so I spent a lot of time, even though I was a little in over my head at the time, I spent a lot of time learning how you build a parser and the front end of a compiler. Because the idea was if we can parse the C++ code, which I later simplified to if we can parse the C code. But either way, it's like if you can parse it, you should be able to do things like rearrange based on semantics instead of rearranging based on text, like manipulation. And so I spent a lot of the time in that 5 years trying to get better at that and figuring out how it would fit in to do all of that. So like I do think I built like a C preprocessor at one point, and that took me a couple months because I was learning it from the first time, and I was doing it in the hardest way possible, which is that the way you want to build a C preprocessor is a file comes in, you start parsing it, and you just find the pound defines and pound ifs and whatever, and you process the text and generate a new text file. So it's text file in, text file out. That's the easy way to do it. But since I was building this for code intelligence on top of a text editor, it wasn't good enough to just have text file out. What I actually needed was a data structure which would allow me to understand the semantics of the code that would be generated by the preprocessor, but without actually building a new data structure that was separate and disconnected from the original, because I still need all of the edits that I make to flow back to the original file, right? I still need to be able to say, if we're going to rename this macro, I don't want to rename it in the preprocessed version. I want to rename it before the preprocessing has happened. So I need not a data structure that is the preprocessed file, but some kind of new thing that I'm inventing that maps back to the original text file and lets me know what everything is, so that I would be able to, in theory, just get the preprocessed file from this data structure, but that it also has that like backwards indexing to the original text file that I'm actually trying to edit. So I didn't realize at the time that I was simultaneously learning to program a preprocessor, which I had never done before, and inventing a whole new data structure on the fly. Like that was what I was attempting to do, but I was in over my head and didn't realize it. So like that's really hard. And in fact, the more you think about it, it's actually like a waste of time, because the next thing you have to do so what happens with any C or C++ program is the way you build it, whether you have an IDE managing this for you or not, is you call the compiler, you pass in the code, and you pass in a bunch of settings. And then those settings can control how the preprocessor will actually behave. So you can turn on and off asserts, you can turn on and off profiling, you can turn on and off debug/release stuff, optimizations, right? All of that can change. And so you can't actually get a proper semantic analysis of a C target file or a C++ target file unless you know what settings you're going to build it with. And you're going to build it with multiple settings. So that means right off the bat, there are always multiple ways to interpret any of the files you're looking at. And so this one data structure I was looking for that told me how to semantically understand just the preprocessing and index that back to the text file also would have needed to be reconstructed once for each build mode you have. And so you would have had to provide the text editor with the entirety of your build plan and all of your targets so that it could figure out what everything is. And once you've done all that, what you would have is still extremely confusing. Like now when I go to do an edit, I have to tell it which compilation unit I believe this edit applies to, like even though it's going to affect all of them. It doesn't make any sense. So I think it's the whole language and architecture of all of it is actually wrong for the original goal. Like you would use a different language besides C or C++ to do what I was trying to do if you actually knew what you were doing.
Okay. How much of the code intelligence stuff actually got into 4coder?
Yeah. So not much. The only piece that I am proud of that worked out was not really deep code intelligence, but it was pushing the... So like the basic code intelligence that you kind of need is like indentation related stuff and syntax highlighting, right? So even if you don't go all the way to the vision Casey had, Emacs already knew how to auto indent your code and how to highlight all the keywords and stuff like that. So I wanted to at least have that much, and that part was all doable. And then the one piece I added was this idea called virtual white space. And this was really cool. And I think this is, besides the customization layer, this is like point number 2 why some people stay with 4coder. It is this idea of virtual white space, because in most text editors, you're still presented with an interface that says this is a text file. And also there's automated or manually controlled indentation plan built into the editor that you can configure. Like auto indent this for me and it'll like fix the indentation of this line or this range you've selected. And if you configure that in a way that you mostly like it, then you get the results you want and you adopt that as your style. And there you go. But usually when you're typing, like little things will get in the wrong place. And so you're typing, and then stop to auto indent, and typing, stop to auto indent. Or you build it in as an automated response. So it's like every time I type a brace and a semicolon, it'll automatically auto indent the line or the range that's applicable. And those sorts of things kind of work. But I wanted to take it a step further, because I felt like this intermediate step of like highlight a range and in auto indent it and then keep going was just an extra bit of busy work. And I wanted to never be in the place where it looked wrong. Like I was like, I know what the code should look like. And more than that, I don't care what it looks like to other people, right? Like my editor can show me an indentation plan that should be separated from the actual storage medium so that other people can have their indentation rules. Say I'm working at some company and they have like, we always use 4-space indents, or we always use tab indents, or whatever. They've got some formatting rules they wanted you to follow. That's fine. I want to follow the rules of the code base I'm in, but I also want it to look the way I like, which is a weird peculiarity of me. I like really small indents. I like to fit as much on the screen as possible. So I use the 1-space indent style where it's like it looks like 1 space on the screen, but because of virtual white space, what you can do is you can say like, I want to separate what's in the text file from the presentation to the user. And so virtual white space is not a configuration of how you auto indent the file, but rather how you lay out the display of the file, so that you can say, I want it to look like 1-space indents, and in the background, I want the auto indenter to do something different, or maybe the same thing, but either way, it's flexible, and different 4coder users on the same project can therefore all agree on an indentation style for the text file, but all configure the layout differently for their own local editor.
Nice. That's cool. No longer issues with the tabs versus spaces, and then like for 8 spaces, like I think GitHub resolves 1 tab to 8 spaces. So if you have something tab indented, not like usually they are converted to spaces by other editors, but if you don't have that and you have actual tabs, they're like super wide. So I guess you would hate it if you like 1-space indents. Nice. What's the state of 4coder now? It's been open sourced.
Yeah.
How does it look like now?
Well, I am only like marginally involved with it at this point. So I open sourced it, like I said, in 2021, basically with the idea that I had decided I didn't feel like working on it anymore. At that point, I think it had been over a year since I had personally fixed a 4coder bug for myself. Like I was still doing things for other users, but everything was the way I wanted it. Ironically, like since then, there are like 2 bugs that constantly bug me, and the community fork has actually fixed them. But what happened was I made the open source version and shared it. And I was like, I don't really want to do this anymore, but I know that a lot of people are using 4coder, and I don't want anyone to just like who's built their own customization stuff. Like people who started building customizations were kind of investing in making 4coder their editor. And so I was definitely not going to take it away and be like, you can't use 4coder. That would have been impossible anyways. It wasn't like I had any DRM or anything. But the other point is like, what if a new version of Windows comes out and something needs to be changed? Or what if there's a bug fix that's actually super critical for a user other than me, but I'm not willing to do it? I'll just make it open source, right? It's like, I'm done. Separately, I also wasn't allowed to make money on it anymore because of a new job. Like I had started working at Epic at the beginning of 2021. So I'd already been done personally for a while at that point. Like I was like, most of 2020, I wasn't on 4coder. So in 2021, when I was like beginning work at Epic, they were like, look, we'll give you a raise to what we're offering if you stop selling 4coder. So I was like, okay, that seems like a fair deal because I'm done anyways. So I just agreed to that and was like, all right, I'm agreeing to not make money off of 4coder anymore. So we're going to like do this transition path. I'd always planned eventually sooner or later 4coder was going to become free and open source. It just seemed like the right time because of that other agreement that was going on. So yeah, that was how it came out. And then there's still like a 4coder website that I control that is not like part of the community's new 4coder fork, but There's a 4coder Discord where I pop in once in a while to answer questions about why I did some peculiar thing here or there. While there's like maybe a handful, like 5 or so people who are contributing fixes and updates and stuff to the community 4coder fork. And it's cool, like even to this day, if I go look at the 4coder Discord, once every couple of weeks, someone new will pop in and be like, hey, how do I get set up with 4coder? And then someone else will be like, try the 4coder community fork, try this custom layer. If you wanted to use Ryan's custom layer, here's that one, like whatever. There's a couple different options to get started or whatever you want, and then people figure it out. So there's there's still a lot of potential in it. I think that I'm also, I mean, I've been told many times that I'm too harsh about the state of the 4coder code. In the open source version that I publish, there's basically a README that's like, here's the open source code, README. Thing number 1, this code sucks. I really cannot emphasize this enough. If you want to learn from it, just don't copy paste all of it, because a lot of it's a bad idea. And I think that's true. Like I do think that if I were to walk through the 4coder code with people, I would be able to say like, this is a bad idea for this and that reason. This is why you shouldn't be copying my style here. But it's also useful because I think there's a push and pull there. I think good style is important. There are places where small failures add up. Like small little mistakes, things that are just not the best way to do something do matter. But on the other side, there's a lot of stuff that I figured out how to do that people are curious about that is in there. And so code, even when I think the flip side of that is if someone else handed me code that did something that I didn't know how to do, I wouldn't say this style is so poor that it's useless. It's like it's still very valuable to have code that knows how to do something. You can learn from that part of it. And so I think, to answer your question about what's the state of 4coder, I think that 4coder is useful to people. I don't personally think it's the best thing ever and should be pushed at like ad infinitum to the end of the universe. I think that there's a better version of a text editor. Like I'm looking at, I don't know if you've heard of Fred. It was demoed a few times here and there so far, but like it's a new text editor being worked on that I'm really excited about. There's a few others that I think are similar. I also have been thinking a lot about the customization layer thing. Like the 4coder customization layer was cool, but there were a lot of difficulties with getting that up and running. So I've been thinking a lot about like, if I were going to recommend people how to really make a customization layer, how will I do that? And it's not the way I did it in 4coder. And so that's one of the things I'm working on too, is as I've been developing this new strategy to make custom layers like the 4coder one way better, I've been kind of pitching that stuff back to the 4coder community. Like, hey, you know how we do commands like this? What if commands didn't need any meta programming at all because you just did it like this? And then it's like, well, yeah, that's true, but 4coder isn't built that way. How, like, this is going to be a huge rewrite. And I'm like, yeah, that's why I think 4coder is a problem in some ways. Like, it's cool, but like, there's a lot of better stuff that I'm figuring out that I want to see take over and replace what I was doing in 4coder. So that's my own analysis of what's going on in 4coder.
You mentioned Fred. What would be the Fred unique selling points that, like, what would bring it to table?
Well, what I like about Fred in particular is that it has a complete history system. So in 4coder, you have undo, redo, like usual, like in modern editors. Actually, not like Emacs. The Emacs undo system is weirder, but more anachronistic. But most modern undo systems are just like you can hit Control-Z as much as you want, and as long as you don't type, you can redo all of the things you just undid with the other direction. As soon as you start typing, you throw away all the old stuff. So one of the, like, Fred has really nice polish on its UI already, and its graphical representation of, like, its text looks nice. Everything looks nicer on Fred. Like, one of the things that I didn't know how to do back in the day of 4coder was good graphics programming. Like, I'd done all this game stuff, but in a game engine, like GameMaker, you're just throwing sprites together. The core of the graphics programming is done, and when there are things like aliasing stuff, you just are like, I don't know what that is. I don't know how to deal with that. It's not my problem. The engine was supposed to, like, it either does or doesn't look good when I call draw line, and whatever game engine you're on either does or doesn't anti-alias that. So it was around the time I would say like 2017 or so, I started to realize I really don't know graphics programming. And I'd already been on 4coder for a bit, but the only thing I knew how to do in 4coder was like rectangles and strings on the screen. Like, that's what 4coder is. In the end, there are rounded rectangles. Like, I cribbed some ideas up from somewhere on the internet about like how to use shaders to do sign distance functions, so you can make really easy rounded rectangles, and they look fine. And that's it. Like, that's 4coder is rounded rectangles and strings. And the strings are okay, but like I kind of didn't know what I was doing there. So there's just like a lot of one way to make something look good, and this always happens in a game project, is that you throw out the playbook and try random stuff until you really like the way it looks. And you're like, that's right. But then there's a way where you can go and learn, like, in theory, what should be happening is that I should be coloring this pixel based on how much the font said here. I need to make sure I'm snapping to pixels. There's like all these like things that are more principled that I didn't really know how to do well, that I think Fred is doing a good job at. But then the other real cool thing is that it has a completely lossless data structure. And by lossless, I don't mean compression. It's like the author to the editor calls it, it's like a pure functional data structure. Now, I still need to go and learn how that works and what it means. But in the demos, you can see that like no branch in the history ever gets lost. Like live in the middle of editing, you can go back, go into a different branch, copy something from that, go back to where you were, paste. So like if you did some work where like this is wrong, you undo all of it, try a different direction. You're like, you know what, half of what I was doing in the first branch was right, and you want it back. Fred doesn't lose that information, and I think that's really cool.
Okay. Interesting. Now we can go back in time a little bit, I guess, to your professional career, because Mr. Forth is like the after you left Epic. Mm-hmm. So Epic was not your first job.
Yeah.
So can you tell me what have you done after college?
Yeah, I did a few things. I worked as a contractor for a year with Casey from Handmade Hero, and I was just working on a little experimental art app. So I had like a drawing tablet and was working on being able to draw kind of like what you would do for the art in a game in like Photoshop, right? It's like we want to be able to draw with the stylus, and then the other piece of that project was to see if we could find a path to sort of automating animation problems a little bit more. So like, I don't really know the full details of what this was for, and it ended up flopping. Like we worked on it for a year and concluded that like the starting point, the premise is just not going to work. So it was kind of like a research project for 1 year where my result was this idea does not work. And so that was that job, which was fun and cool. And then I switched to working at Rad Game Tools after that. Because, you know, Casey's connected to those folks over at Rad Game Tools, so it was easy to make that transition, thankfully. And so I started working at Rad Game Tools and did the Rad Debugger project for like 5 years. So I think Rad Debugger came out, like the public version that's out now, came out in 2024, if I remember correctly, like near the beginning of 2024. So it was like right before I left. Like I was kind of running the project all the way through prototyping and main development, and then I like hit that 5 year point. Like it was 2018 to 2023, and I was like, well, I really liked this job. The transition to Epic is not terrible, but not exactly my favorite part of what we were doing. And Ryan has joined, and he's like, I've taught him a bunch of what I have figured out, so he's going to be able to take over, and I'm out. Like I just am done. Like this is as much as I want to spend on the debugger project. 5 years, and we did it. And I left just before we actually got it over the finish line because I was at that limiting point again, I feel like. So
your alarm set to 5 years popped up in your telephone, and you needed to answer the call.
Mm-hmm. So that was it. I mean, that was basically the two jobs. The Epic was the same job, right? We were still working on the same stuff when we switched to Epic. So yeah, that was basically my professional experience from out of college through to Mr. Forth.
How did you like working at Rad, and how does work at Rad look like? In terms of like organization and
well, it was really cool to work at Rad. The everyone there who was super smart and had their own like gigantic amount of experience on cool, usually games related stuff. And so it was just cool to be around and hear the kinds of things that they were thinking about and stuff like that. The company itself was organized as basically a collective of individual project maintainers, right? So it was for basically what I had done in 4coder. One person makes a thing and gets it out by themselves. except that everyone there was doing that with a different project. So it was like a company made for people like me. It felt like I liked it a lot. Some of that culture was lost when it became Epic. Like it didn't happen all at once, but like that was what I liked about it, was the fact that we could all kind of work independently. So I could spend as much time as I wanted rat holing and stuff. Like with the debugger, a big part of the reason to make the whole thing was to get a debugger onto Linux. But the problem is that nobody's done that very well. Like we didn't have a template to copy of what that looks like. The only good debugger we knew of was the Visual Studio one. Like that's the one template that works. So over my 5 years, I was handed this project that was like already half done in several different styles. Like it had been going for 10 years, I think, when I joined. So there was just like all this old code from other independent people working on it. And I kind of started picking it apart and learning it and realizing that like there were not incompatible style choices throughout the whole thing. And I'd already learned from 4coder that actually does bury a project. And so my contribution for those 5 years will be like, let's unroll what has been done, learn from it, and also let's stop trying to put this on Linux. Let's just do Visual Studio on Windows, nothing fancy. Just copy what we already know how it works well and get that up and running first. That way we know how to make a debugger. And so we did that, and I also still had that vision of porting to Linux. So a big part of what I spent my time on was, even though the goal that I have set up was to get us to Windows, I'm independent in the way the company's functioning so that I can spend as much time as I want prepping for the Linux port. Like I was able to go through and be like, here's the abstraction layer that we're going to use for process control. Here's the abstraction layer. Getting the abstraction layer for debug info turned out to be the hard part, and developing the rad debug info intermediate was the final like solution that I landed on that actually felt like it got it done. Like I said, I didn't stay for the ship, and I don't know that it's out on Linux yet. So it's not actually done, but I hope that in theory that those decisions for abstraction will actually allow it to get to Linux. I spent a lot of time not making visible progress because I was just researching how will this work on Linux, because I was free to do whatever I wanted.
I've seen some super early alpha tests of Ryan on Linux.
Nice.
Some Windows like existing there, but I don't think it's already in the state.
Yeah, there's a lot of stuff. I had 4coder on Linux, and I didn't do that either. I actually had someone contributing on that side most of the time. Because like learning the X window stuff, the Linux windowing and all of that was just not something I wanted to do. And it is a lot. Like it's a much more difficult API than the Windows one for setting up windows, for grabbing events, for decoding them and stuff. It's more work.
Nice. Rad. I know at this point it's Epic, so it's kind of like a bit over for this journey, or like style of company, at least there. But it seemed unique in the sense of you have your own project, you have ton of responsibility assigned to you, but you have the best help you can hope for. Yeah. And you're given freedom to do what you think is right. Yeah. And it's very unique.
Yeah. Totally. I think that freedom to do what you think is right is the super, super unique part. I mean, it was, as far as I ever understood, it was a fairly successful company, but it was also a research company. Like in a lot of ways, if you look at that structure, a company that can afford to spend, 15 years with a back burner project trying to figure out how to get a debugger put together, that's like a research project at that point. Not knowing, like having a product that takes that long means you are spending more time figuring things out that you don't know how to do, which to me isn't development. That's before development. You're like, just how to answer the question, like, what do you even do? Is it like, what are the ways to make it possible? So I think that it's unique because not many research companies that I know of manage to exist without chasing hype. Like I think if you look at larger tech trends, most tech companies are AI companies right now. If you're doing research, that means you're doing AI or maybe some other like hype related technology you might be involved in. But like, where do you find someone who's just doing the plain boring research of, like, practically speaking, how do we get debugger that looks like Visual Studio on Linux? Why isn't that? Is there a reason why that's not happening? Is it just a development bottleneck? And I think more often than not, it's like you actually need someone who can do research style work to devote to something that is already known how to do it in theory. Like, most of the time, research is trying to push the bounds of what we know how to do in theory and understand why these new theories work. But I think there's also a place, at least in technology, from my own experience at RAD, where you need something that sort of operates like research, where it's open-ended, you don't know how long it'll take, you're trying to figure something out, not trying to build something yet. But what you're trying to figure out isn't it's just a practicality. Like, in theory, we know this should be possible to do, but practically it's not been done. So what's the disconnect? And I think that was what was so cool about RAD, was that they were willing to spend a lot of time answering, like, practically, what does it actually take to do this thing which is perfectly possible in theory but isn't being done.
Yeah. Well said. Now, when we switch to the Mr. Forth now, right?
Yeah.
Because you leave Epic to start your own personal brand, Mr. Forth. Mm-hmm. So tell me, what was the vision and how is it going?
Yeah, so my vision was, I really liked that research stuff. I wanted to do more of that. Like, I wanted to do more of what I thought was happening at RAD, although not entirely games focused anymore. Because, like I said, I've been torn about, like, I love the making games stuff, although I don't think my own skill set is 100% built up to be games technology. So what I mean by that is, like I said, graphics programming, turns out I never really learned how to really do it right. And I've been learning that recently, but I'm not the right person to go and do graphics programming technology research because I don't even know the basics, right? What I learned from the 5 years at RAD/Epic on the debugger was more, and what I also learned from 4coder was, like, development tool stuff. Like, I learned how to build development tools. And so I liked that research style thing where it's like, it's kind of open-ended. We don't know what we're going to sell, but we are hoping to at least learn how to do stuff. And if we learn how to do something that's valuable, then maybe we can sell that, right? Hopefully. And I was just like, I want to go back to working like that. I don't want to, like, what had kind of happened, and I think that this is another piece of what happened at RAD that I never participated in because I left after 5 years. But at a certain point, it transitions from get this thing ready, figure out a good thing you could do, to now maintain this in perpetuity for a while, right? Like, make a product out of it and make it so people can use it and build that part. I sort of left when that was going to become the new status of the debugger project, right? So I was doing the how do we get this out there? How do we got it up to version 1 essentially, and then after that, it's going to be like, well, there's going to be porting, there's going to be project system iterations, there's going to be all kinds of how do you make this a better product stuff, which is fine, but, like, especially if you're already at your sort of limit, like your burnout limit, you're like, I'm going to be bored of this project. I definitely don't want to be on the part that's just maintenance. So it's like, maybe there's a blind spot in my own vision there where it's like, I don't actually have that much emphasis on getting anything in particular done. I am hoping that I can sell people on the idea that this practical research stuff actually pays off, right? So my thought process after the experience at RAD, but also there was a separate thread of experience that started happening in 2020. So when, 2020 was the pandemic lockdown year, and so that looked different for everybody. But for me, that meant that I had a whole lot of new free time, and nothing really was going to be able to interrupt me from using it however I wanted. So in some ways, it was a really great year. It was kind of, again, I know it sucked in a lot of ways too, but it was like kind of a really great year for me. So I got really into this idea of, like, okay, the 4coder project was originally about this high-level semantic editing thing. That still seems valuable to me, but I'm no longer convinced that I can do that by just throwing a new editor on top of C++. Like, I kind of learned that's not going to work. So I started thinking about, like, what is the next step for that vision? Like, do I want to keep pursuing it? And if so, how? And the path I kind of ended up on was this path of, like, I want to master the the particulars of how the tool chain that we currently have works. So specifically, after spending enough time around this, you get used to the idea like you have text files, and then text files get converted into your program, and they also get checked into Git for a repository, like a version control, and they get edited in your text editor. So the text file is like, it's just a file in the file system at one level, but it's also a choice of the entire ecosystem to have all the other tools for development speak this particular data structure as its main language, right? All the other tools work together. The reason my text editor, it doesn't not need to have Git built in, just the fact that they both say text file is the interface means that they talk to each other through that interface. Same thing with the compiler and compiler diverse, like it all, it's the central point. And my new idea was I want to get good at understanding all of the spokes on that wheel, because I really want to nuke the text file out of the center and put something else there. I think that's the long-term vision for a new paradigm of programming where high-level semantic editing, like what Casey was pitching, and what I don't even know what he had in mind, to be honest, right? Like, we could go back and watch and ask him. But what I had in mind, listening to what he had to say and thinking about it for the years I was working on 4coder, what I had in mind, I think, will become much more possible in a world where the text data structure isn't the center of the system anymore, because the text data structure for any of the semantic stuff I want to do it has to go through these translation steps, and those translation steps add a bunch of structure. So like they don't add structure, they discover the structure from the text file. Like there's a structure hidden within the symbols of the text file. It finds it and uses that. What I am convinced of at this point is that the text file itself, another piece of this is it's hard for me to pick it all apart because I've spent so much time thinking about it. It's not one text file, right? It is a tree of them that we use as the central data structure because it's in a file system, and we always are using multiple of them. So it's like a tree of text files, or something like that, is the data structure that we use as the central hub. And while it gives you some opportunities to create discrete differentiation between things, so I can put stuff into separate files, that has usually been already assigned a meaning by the language, right? The language is usually already kind of telling you what you're going to have to do in terms of what goes in a file and how you do file divisions. Now, like, there's flexibility. You can make some decisions about, like, okay, the language will allow me to, and see, it's very free. I can use lots of pound includes and stuff, but there's still limitations there. There's like, you can't, if I end up deciding that the best way to organize this would be like everything will be in its own, every command in 4coder will be in its own file, for instance. We are going to have one separate file for each command. That'd be crazy, right? Unless the preprocessor had like include all inside a path, but it doesn't. So those decisions are baked into the language about what the tree of text files does and doesn't mean, is what I'm trying to get at. So the point of all that is I wanted to master this data structure idea. Like how does the text file relate to each of these tools? If I can get good, so I've gotten good at the text editor part, I've gotten good at the debugger part. I left that out of the wheel, but that's one of the spokes on this thing. There's the compiler part and there's the version control part. So I haven't done a project like either of those, but I do intend to learn them sooner or later. But another piece I want to learn is just how do you go about designing data structures, right? I wanted to get really good at that part too. And in particular, I don't just mean one data structure, but how do you make a plan for how information is organized that you can implement in multiple different ways? So the big idea there is like when you save stuff out to file, it's in text file land, you never actually think about this distinction. But in files, it's sort of a serialized format, or sometimes what I call like a cold data structure. It is laid out in such a way that it means the right thing, even if you copy paste it somewhere else. Like the sequence of symbols in the blob is all you need to reconstruct the meaning. And then there are data structures that are baked into the runtime of a specific program. They only mean something if you can resolve all the pointers that they have to other things inside the same program, right? So the web of pointers inside of a program creates a hot data structure. It's ready, the memory access is ready to go through those pointers. It's ready to do things fast. But if I take one of the data structures and relocate it, it breaks the whole system, because now the position of these things matters. You can't just shift things around when other things are pointing at each other. You lose the connections. The the distinction there is not obvious with text files because it feels like you never switch to a hot data structure. But internally, there's a small little buffer. There's some kind of hot version of your buffer, which is different from the text file, right? When you look at if you look at 4coder, in my version, it's a gap buffer. So the text is not cold, as in it's not just in a text file anymore. It's in this data structure called a gap buffer. And in Fred, it's a different kind of thing. And in every text editor, it's something different. I mean, you could, in theory, use the cold data structure, but it's a poor data structure for editing, performant editing. So the point of all that is to say, I believe that this pattern of you have cold data structures, which are storage and communication between programs, and hot data structures, which are compilers and editors creating these higher performance structures that contain all the same information, right? It's the same information content, but it's a different encoding set up for a different purpose. I've been spending a lot more time trying to fully get my head around what are the relationships between these hot and cold types of data structures, and what are ways of organizing and planning out the information content that a data structure is going to support, independent of the features it has as a performant in this way or performant for that purpose, right? Those secondary things are performance optimizations that I think of as the encoding, different various encodings, but they're all encodings of the same main information. That main information right now that we use for programming is text files. And so the big pitch that I did with Mr. Forth, taking this full circle finally, is I want to do practical research, stuff that will make it possible to program in new ways. And if that's valuable to other people, hopefully they will want to become a member of my Mr. Forth. So on MrForth.com, there's a membership thing. So the way I set that all up is I'm going to do this research. I really don't know if I'm going to ever find a product to make to sell. But if you know my work and you think that what I'm talking about, or you just believe in me for whatever reason, then you can go and support me, and I will try to make these things come true, right? That's the pitch. I don't know if it's a viable business model, but that's what I wanted to do because I really wanted to work on these projects. And to answer your question of how is it going so far, I really love the freedom to work on these projects. I've been going a little farther into trying to get some of the information about what I'm thinking about out. So I've started a new video series about that. So in terms of getting the things done that I'm interested in getting done, I think it's going well. But like I said, still yet to be seen if it's a viable business model because I've only been doing it for a year plus a half or so. So, yeah, I don't know. It might not be a thing you can actually do for a living indefinitely. We'll find out.
For such an abstract project or research project, how do you keep track of your progress or even direction?
Yeah. Well, I've been trying to focus on a few near-term goals that I can deliver on. So basically what that looks like is I know that I can't get this whole thing done anytime soon because the pitch is that I'm going to swap out text files with something else. And then for that to be meaningful, I at the very least need an editor for the new data structure, a version control for the new data structure, and one language with a compiler for the new data structure. If I had all of that, then I have a thing to put out. But and ideally at some point a debugger too, right? But that's stretch goals for this kind of stuff. So I don't expect that that's going to be delivered anytime soon because there's just so many different things and I'm one person working on it. So I've tried to break it down into separable little pieces of where I think the right direction is, right? So I don't know. The hard part here is once you know what that data structure should be, if you can make a conclusive statement of I think we could switch to this particular information. Instead of a tree of text, maybe it's a database with text blobs and keys or something. I don't know, but just throwing out a different thing that would be a little different. And maybe you figure out that actually the properties of this data structure are going to be what pays off, that vision that I should be able to do things like grab the local variables out of a function and turn them into a struct, and then find the same local variables in a different function and collapse that to the same struct. Like that is a very high-level semantic idea that requires type checking and the ability to do these high-level edits. You can do that on certain stages of the compiler, like in its translation of a text file to the output, there are some intermediate stages where it becomes relatively easier to see how you would do stuff like that as an edit. But those data structures are usually designed, right, not for editing purpose. So when you're talking about this data structure theory stuff, we can stop, pause, and go like, okay, in theory, we know. Again, this is the difference between we know in theory this is possible, practically why isn't it happening? We know in theory that all the information that I need to apply that crazy high-level edit of grab some local variables in this function, in this part, in this function's local scope, turn that into a struct, and then do the same thing to a different copy of the same variables into that same struct. That is all perfectly reasonable in theory because we can just look at the information content of like the type-checked abstract syntax tree. In most compiler architectures, the information you have there should be enough, but that doesn't mean you've encoded it in such a way that it's actually mutatable in that way, right? So there's that piece of like usually you're encoding it so that you can do the next stage of compilation, which may have very different needs than rearranging the tree and the types in this way that I'm pitching, but I'm not convinced. So in 2020, me and Ryan worked on this project called Dion together. And we did a few projects together after that too. But that one was about what would it look like if you just took something that was basically the information content of an abstract syntax tree and turned it into a mutatable data structure and built an editor for it. What would that be like? And the lesson was that's not the right thing to do. And the reason that's not the right thing to do is because it gets a little abstract and hard to talk about. So the way I conceptualize it is when you build a data structure, right, like a text file or something, tree of text files, you have, and once you've defined your data structure, that sort of induces a space of all the possible instances of that data structure, right? So if you just simplify for a minute, think string. String is a data structure. The space of all possible strings is implied by that. When I define what a string is, now there's this abstract mathematical space of all the strings I could instantiate. And so what an editor has to do, if it's any good, if it's an editor for strings, which is what we usually use, essentially, then all it has to do to be complete is provide some way to get from any string to any string through its editing capabilities, right? If there are strings that it cannot get to, then there's something wrong with your editing scheme, right? Like, it should be complete in that way. And then, of course, you can also look at it in metrics of like how many edits does it take to get from where you started to where you want to land, right? If it's a lot, or if it's super counterintuitive to find those edits, then you have a different problem, right? So the navigation of this induced space of possible values is the thing I was looking at, and I realized that when you're on an abstract syntax tree and you start looking at the edits you need to edit that, compared to the edits you need for a text file to be complete. For a text editor to be complete, all you need is the ability to insert any character and the ability to delete any character, right? That's enough to be complete. And then everything else you add on top of that is just convenience so that you make those edit distances as short as possible. The idea with an abstract syntax tree generally turns out to be that you need so many more edit types. Like you can't, it's not just insert a character, delete a character. It's like for every kind of node I can insert. Maybe I can make one insert that's like for all nodes, but it turns out sometimes types of nodes you want to insert affect everything around them differently than other types. And so you need slightly different editing semantics depending on what you're doing. It's a little rusty what those things were like now, to tell you the truth. But if you look at like there's also research literature on the same idea. It's a topic called projectional editing. It's the idea that you have a data structure that you have an editor for, and that editor has an editing scheme that can complete the data structure. Like it's complete in the sense that it can get to any copy, any instance of the data structure that you want. But when it's a projectional editor, instead of just like a normal editor, it also means that it's always a valid program, right? You start with a valid program, and every program you can arrive at is one of the valid programs. It always means something. And that's cool, but imagine you have this space of strings, and then you look at all of the ones that are not valid C programs, and you delete them from the space. What you've done is you've made the space way more sparse. Right now, the points, the field of points you used to have is scattered all over the place, has shrunk down to like little stars. There's one here, and then there's one with a main the main function and its open and closed brace, and that is so far away from the empty file that it's like, well, what's the edit for that jump? And if that's not an edit, what are the intermediates? Like, is there an edit that goes create an unnamed function? Well, that's not allowed in C. So like you start realizing that this restriction of always being a valid program generally means that you've decreased the density of points in the space of what your data structure is allowed to contain. Now, if you've designed a data structure that is itself has this property that it's always valid, or if you design a language, like you could do this with text, right? Take a language and just say any language, anything that doesn't compile, I'm going to find some way to make it mean something. So you could do this pretty easily with like esoteric programming languages, right? So for instance, there's the classic example, brainfuck, is actually like this. It has 8 characters that mean something and everything else is ignored by the interpreter. So every text file is a valid program in this system. That's fine for that very esoteric case, but you don't actually want that in serious programming architectures, it turns out, because if every program is valid and defined, then what does version 2 of the language mean, right? What version 2 of a language, the next version of a language usually means things that weren't defined before now have a meaning. It doesn't usually mean things that used to be defined this way are no longer. I mean, I know like Python went from 2 to 3 and old stuff that worked broke. So it happens. But I don't think people like that. I don't think you like when you are on a language and you have something that is defined by the language, and then in the new version, the thing that was defined is now defined in a different way. It doesn't mean the same thing anymore. You just don't want that. You want the things that were defined previously are fixed in place. So again, using that vision, that framework of the field, the space of all possible states that your data structure can be in for your program. Imagine instead of deleting them, you're coloring them. Some of them are green, they're good, they compile, and some of them are red, they're bad, they don't compile. And you decide that they're all green. Then with that, usually the red points, the ones that don't compile, are the space to expand the language. But when they're all green, now you have to modify previously defined points to add new features. So it turns out, after looking at all these things, that I just don't see any way that the current architecture is wrong, besides the fact that it's text files. Like everything else about it is right. You want languages that only define a subset of the data structure as valid. You want editors that can construct invalid programs. You want simple editing schemes that don't require 5 different operators just to be complete. You want all of that, but you also just want better structures built into the core than what a text file gives you. You want some kind of key index system. You want some kind of discreteness that is missing. And so I am kind of on this journey. Like you said, what the question was, it's all very abstract. How do you pin it down? One of the big points is, what is that data structure? I don't know, but I am doing experiments like C scripting to figure that out. So there are these experiments I'm doing of trying local near-term things we can actually start programming with. So actually, this kind of ties a lot of the things we've talked about together. I mentioned that I have been finding I miss the making games part of why I got into programming. So one of the projects I've been doing is to build a game engine, but using this thing I'm calling C scripting as one of the core drivers of how the engine works. And C scripting is not a new data structure at all, but I am modifying the way I think little pieces of C code can connect to the whole in a direction that I think matches what I hope that a new structure will have more deeply built in. So it's sort of a first step is get the C scripting thing out. It's practical because you can already use it. I'm already using it. I'm iterating on the details of like what goes wrong with it, and I can tell you a little bit about how it works if you're curious. But the point is, like, you can use it, and other people could start using it. It's real now, and it reveals things that do and don't get easier. Like, well, now that I have this tool working in C, it's a little bit of a hack in C, and I think it would be better on a different system. But we can explore what it's like to have this more piecemeal composition thing going on and what does and doesn't get solved well. But I'm still in C, so anytime that this magic bullet isn't actually a magic bullet, I just go back to using the other thing I already have that works well, which is program it in C, using all the other tools I already, like all the other techniques I know still available. So that's one direction. And then the other big direction is the data structures thing. Abstracting the specific goal that I have for this data structure that replaces the text file interchange. The more generic thing to ask is just like, how can I talk about and pin down the things that are and aren't like rigorous in the process of picking out a data structure? Like if I want to talk about, hey, I'm going to have this database kind of thing, and it's going to have a specific semantic meaning. I kind of want not just to grab SQLite or something, but I want to say like, we're specifically expecting a particular scheme or something. And the reason that I'm it's hard because I'm trying to figure out an abstract way to put the point without making it concrete in the wrong way, right? But I want to be able to talk about like data structure design skills that I am finding I will need to be good at myself, and that I will need other people to understand in order to get there. Because a big part of my assumption here is that I'm probably not going to ship those 3 starting tools that you need to make a new data structure. At best, what I can do is probably arrive through the C scripting experiments at a pitch, and then maybe a demo of an editor and a language or something. But I'm probably at some point going to need a larger community to believe in my idea too. And so a part of the project, is to just take my particular scheme of like thinking about this and make it available to everyone, so that if I do come up with a solution and I try to explain it, that the language that I'm going to use to explain it is already available to other people to understand what I'm talking about. So that's what the data structures, like I've got this new video series I'm working on about data structures, kind of just going through all the things that I have been learning about. And some of this comes again from like academic literature on like, like the sort of abstract algebra type theory side of things, like thinking about the structure of information kinds of topics. And some of it's just my own homebrew. Like I learned some category theory, but I threw it out from how I talk and think, because I don't think it's a little too jargony for me, especially when I'm trying to explain it to other people. But I love the arrows and the diagramming that it taught me how to do. And I'm trying to make a sort of back of the envelope version of that for reasoning about programming. And while I don't think it's perfect, I think I've made some headway on how to do that. And so this is stuff I'm trying to share about how I'm going about just thinking these things through.
There was a lot, but I continued, and I think I got it in my head. So nice. I think we're on the topic. To wrap up the last 2 points you made, you said that you're having both the work on the C scripting part, which explores the idea of a new thing, like new paradigm, replacing the default text file as a default text data structure. And then you have a video series that you started on data structures, but more like an information theory.
Yeah.
Okay. Now, on the C scripting side, how does it look like? What's your best approximation of this new data structure that would replace the text file?
Yeah. So I'll tell you very practically what I'm doing first, because I think that I've already given so one of the things I've learned about information theory, and I dropped my interest in category theory off on the last breath I was giving previously. So something I learned from that is that it's very often useful to view everything you're dealing with regarding information from a top-down and bottom-up perspective simultaneously. So the category theory stuff and the arrow diagrams, that's a top-down perspective. You don't talk about what's inside the information. You talk about how the different types of information relate to each other, right? So this is the relationship network. And then the bottom-up structure is more like the set theory, the data, or it's like the nuts and bolts. How do you put it together? Low-level thinking. And then I think that if you get the explanation at this level and you don't get it, and then I give you the explanation at this level and you don't get it, but I explain it all together. Eventually, that helps to put it all together. So here's the bottom-up version of C scripting. The bottom-up version is when you compile a program, if you look at the data structure for the program itself, it is just like every other data structure. It's got some informational content, and you can use that to do more than what we generally do. So it contains at the top level, it's like a header, and then a bunch of data sections. And each data section has a few pieces of information. A very small name, it's usually like .data, .text, .debug, whatever. And then a data blob. And then the data blob can be in all sorts of different formats, depending on which section it is, what role it plays. So if it's a .text section, it's got the machine code. That's the stuff that actually executes, right? It comes from your executable code. Then you have .data sections, which contain your global variables. You might have .r data, which contains the global constant variables that you want to have marked as read-only. And then you might have debug info of some amount stuffed in there somewhere. And you might have, there's other stuff. There's like exception handling tables and stuff. So there's all these different tables and sort of stringized and sequences and stuff smashed together into data sections. And there's only a few of them that are like defined, like .text, .data, .r data. A few others that are like, each of these is per operating system, per compiler, a little different. But there's a bunch of open space there. There's like a whole bunch of those. So you go back to the analogy, the framework of the space of possibilities. In the space of possibilities of executable formats for both Windows and Linux, there's a bunch of red dots. There's a whole bunch of unused space about where I can go and say, I'm going to define new semantics by taking this unused piece of the space and defining new meaning here. And so what I've got is I can create, this is not standard C. So a big part of C scripting is that you have to embrace non-standard extensions to your C compiler. So the non-standard extensions that I'm embracing are two things. One is the ability to create new data sections. Those data sections I was telling you about, you can just say, I want to create a global variable, but I don't want it to go into .data or .r data automatically. I'm going to assign a data section. I'm going to give it my own name. I'm going to do whatever I want with it. And then the cool thing you can do with that is you can now make multiple global variables that are all in the same section together, and then assign your own meaning to that data section at the end, right? You can write your own code that assigns meaning to that data section. So the built-in program structures say, like, here's what the executable code means, here's what the global variables mean, here's how it all links up. My thing just says, okay, cool. I want to say that, I'm going to think of a good starting example, 4coder commands. Okay, 4coder commands are important to 4coder. They basically they're made up of three pieces of information. A function pointer to the actual command code, the name of the function as a string, so it can be displayed inside of 4coder, because the C code has the function name, but the compiler doesn't preserve that by default, right? That actually is missing from the executable file. So separately, you need a string. Somewhere in your data, there needs to be a string. It could just be in the .data section, but a string that is the same text that you use to name the thing in the code. And then third, that documentation string that tells you what does it actually do with like a full sentence. And so those three pieces of information want to be like a struct, right? Function pointer, string. And then I want a table of those to make up all of my commands, right? So that's the informal, like, abstract data structure that the commands should be made out of. If you look at how I did that in 4coder, the way I had to do it was like pre-processing. I ran a special pre-process pass on the custom code. Then I ran a custom meta program on the custom code, which everyone who builds custom 4coder layers now has to do both of these. Like, they have to use my build script that runs the pre-process, but not anything else, parses the pre-process content, and then runs the full build finally. So this is meta program. It's this whole meta programming thing that has to happen. C scripting says, well, what if we didn't want to do metaprogramming, but we still want the table? Can't we just organize that together? The way we would do that is we make a new data section called .4cmd or something, 4coder command, 4 command. So we'll make a .4cmd section, and I'll put a bunch of structs into that section. And those structs will be a function pointer, a string, and a string. And so now I've got one data section with all of that data organized in one place. And the compiler does not technically have to lay those out in a way where they're packed like an array. But it turns out it does anyway. Like the language doesn't define that all this stuff thrown into a data section is laid out in any particular order, and that it doesn't, and it also doesn't define what needs to happen in terms of padding between global variables in this data section or anything like that. It's all undefined. So compilers can do whatever they want. So I am just embracing the assumption that is absolutely wrong sometimes. It's like, this isn't just undefined behavior, but it's good enough. It's like, it is wrong sometimes, this assumption, but the assumption is it packs it like an array, right? And then the reason that is sometimes wrong is because the compiler sometimes wants to add some padding that has nothing to do with the normal alignment rules, but it's like global variable alignment rules that are a little different and weird stuff like that. And so I've had to, this is where the research happens. Like, practically speaking, the reason you don't do this is because there's a bunch of little just issues that come up. And so I've been grinding through those issues, figuring out the best ways to stand off the corners and say, like, look, I know it'd be nice if you could just do this as it was. I'm getting as close as we can to that. There are some trade-offs I have chosen. Like, for instance, in my current iteration of this, you cannot use an alignment smaller than 8 bytes because of the fact that I find it so hard to figure out what all the different compilers are doing at smaller alignments than that. But at 8 bytes, it becomes more regularized where the padding is going to show up. And so that's what I've got so far, and I'm trying to make it better. But this is where I'm saying it is a hack. It is a hack on top of C. But the programming model it enables is called, the reason I call it C scripting, there's a second prong here I want to get to too. But the first prong here of putting things into data sections feels a lot more scripting-like because of the fact that if you think to like what it would be like to make a command system, the metaprogramming system was one way to solve this, but one way or another, you want the situation to be, I write down, begin my command, here's the name of my command, here's metadata for my command, here's the C function block that describes how the command operates, and that should be it. Like, I should be able to put all of that down, and that should be it, and now the command should exist inside the system. But the problem is that C does not have any features which comprehend all of the things in its global scope. Right? There's nothing I can do in a C program that says, iterate all my global variables and their type information from within the program itself. That's just not a thing. That's why metaprogramming is the solution when you just go like at a first crack. It's like, it's just a missing language feature, so you metaprogram it and you parse your own code, you find this data table, you build the data table in a separate C file, and then you include that into the final build, right? That's the metaprogramming approach. So the C scripting idea is just like, well, no, I'm going to put it into a separate data section, and then I'm going to write one like piece of code at startup whose job is to examine. So when you're running a program, the data file that contains that program gets loaded into the memory space of the program, right? So you have a file, cold structure. Again, this whole data structure thing, I keep finding I want to use it. The program is in a cold data structure, the executable file. When it loads into your process, to create a process, it becomes a hot data structure. It's a different data structure called an image. So there's like the image file, and then there's the image of the program while it is running is a different thing. It's largely just mem copies of the original file's data sections, but the layout is a little different, and some data sections don't get preserved. So it's a little different in layout, but interestingly, the cold structure in this case contains instructions about how to arrange the hot version, like where things get laid out and stuff. So you can manipulate, when you're building the program file, how you want this hot version to work. And so you can say things like, once I've got the hot version, in other words, once the process has started, there will be this data structure splatted out into my memory space. Now, again, C doesn't have anything built in to deal with that. But if you know what format you're in, like if you know what format your program is running from, then what it can do is go to the operating system and say, hey, can you give me the base pointer for my module? Like when you load this program in, when you load in an exe or a DLL, one of the things that always happens is the operating system picks one contiguous range in that process's memory space and puts the entire thing right there, right? It's like the entirety of this DLL or executable is going to be inside of one single range. And so if I can go to the operating system and ask, hey, where's the range for the current module, executable or DLL, whatever it is, it can give me that. And what it gives me is a data structure that I know how to parse. So I can then parse the header. I can then find the data section called .4cmd from runtime code. And so I can very easily construct the pointer and the count from the data sections without having to do any additional sort of linking up, right? I don't have to manually link up a command. I can write a command with its extra data attached right in one sort of declaration macro. I have to use the preprocessor quite heavily. So in addition to abusing undefined behavior on these extensions, I'm also like talking about massive amounts of preprocessor work that has to happen to add this new structure to C. But once it's done, you go like command parenthesis the name of the command, comma, the documentation string for the command, parenthesis the code block for the command, and it's automatically being registered because of the fact that it's in a separate data section, and that data section acts like an array that you can just grab at startup. So it's like perfect. It's like exactly what you want. It's not even going to have to go through serialization. The compiler is already doing the data packing the way I want 90% of the time, right? So that's the idea. Is like I like having the command system not have a meta program. And most major compilers have this extension. It's not standard C, but it's common unstandard C. And the few places where they don't agree, I've found I can shave off the rough edges by just disallowing certain small configurations that you might want, and that's where it's a hack. But the way this enables me to program is now, and I call these things symbol sets. So each one of these data sections is pretty much always I'm exclusively using it this way. So you could, in theory, use it in other ways. Like you could put in things that aren't homogeneous structures. So like right now I'm talking about arrays of a single struct type so that we know where it all is. If you had some more guarantees from the compiler about how it would lay things out, you could go farther. You could say each one of these will be non-homogeneous, but they'll have a 1 byte or a 4 byte code at the beginning that tells you how big it is. So as long as they're packed without padding, that's the part that's not going to work out. But if they're packed without padding, I should be able to parse it. So like there's a lot more you could do in theory, but I want to keep it as simple as possible. And the other big assumption that I'm taking is that I will never be able to guarantee what order these things get packed in. So if it matters that one of them is the 0 slot in the array, or that one of them comes before another one in the array, I can't guarantee that from this system because that's a part of this undefined behavior that looks to me too hairy to try to untangle. Yes, 90% of the time it comes out in the same order that you write the code in, but once in a while it doesn't, and I don't want to figure out why. That's really hard. So so there's some hacks to it. I embrace that these things come in an unspecified order, and at startup I can comprehend them. And by comprehend, I mean I now have a way to iterate an entire structure's contents. I don't have to know which global I want to talk about ahead of time. I can discover this global information from some kind of root pointer to the whole thing, right? And that lets me automate all the rest of the work. Like if I want to index all of the documentation strings, well, that's just a startup thing now. The table's already ready, right? It's there. You can then extend this to have multiple of these instead of just having commands. Imagine now, like I was saying, I've been using a game engine project to actually push this as far as possible. So in the game engine project, I'm doing things like every sprite is one of these symbol set things. Like to make a sprite, what you do is you say define sprite macro parenthesis the name that you want, the symbol name you want for it, comma the file name for it, parenthesis close, right? Semicolon. And then if I want so a little bit of context about the game, it's like a 3D environment with 2D sprites in it. And so if I want to set up an environment generator, I'm be like, here we're going to generate the background environment and then put the main sprites of the game into play after the fact. The main pieces go on the board after I've generated the board, background, and stuff like that. So the generators, each generator for an environment can now be one of these things. And so now I have an array of all of my environments with symbol names that I can use to just execute the construction code for that environment. Same thing can happen for animation systems. I can say, okay, I want to have hand-scripted animations for how characters move around in scripted ways. And the timings and things like that, I'm going to organize those together into single C scripts, into single, like a set of all the animations, and they each get a name, and so on and so on and so on. So I've been able to go all out on programming this way for a while and that is, I think, the step in the right direction. I think the big thing that I want to see in a new kind of programming that text files kind of struggle to emit, although, like I said, I'm kind of figuring out how to do it in C now. There's a lot of problems with doing it this way. But the thing it kind of allows for is this new flexibility to say, like, I now have this one tool of being able to say that I can declare stuff from everywhere. and comprehend it into single structures later to automate things, just allows me to be a lot more free. It's like it's more flexible than like the way object-oriented programming is supposed to give you the same kinds of things. So if you think about like, we could take this from a whole different angle if you like, and I can explain why this kinds of stuff is useful by looking at the breakdown of like, what's the difference between an object-oriented vtable approach to a switch approach for programming game entities, as a specific example. What happens with object-oriented programming is like, I've got an entity type and I've got some vtables for it. Like I got some virtual functions which form a vtable, and then my other classes are going to inherit from that and fill in like, here's how you initialize, here's how you step, here's how you draw, maybe here's how you collide, like whatever your game needs, right? And then the way that organizes code is so that everything pertaining to each object type goes together, but everything pertaining to drawing is spread out across the code, right? And if you look at the same problem, but you say, I'm going to solve it with a switch, so everything's not going to have a vtable that's hidden from me in C++, but I'm going to use the C approach of everything's got an enum value baked into it. And so the draw operation in my program is one draw operation, which has a switch with a case for each entity kind. Now, all of my draw operations in one place. If there are any things that are like specific and special about drawing, it's all grouped together. But if there's anything specific and special about the player object, it's now spread out, right? So now those things have to coordinate long distance, but drawing doesn't. You can't get away from this with text files, period. Like one way or another, you slice it one way or the other, or you disintegrate everything and now nothing is near each other, right? You can make really tiny text files, but you haven't solved it. You've just made both problems happen simultaneously. So the weird thing about that, besides how it's organized in text, is it also implies a particular low-level organization of how it gets implemented, right? So the text organization is coupled to the performance implications, right? If I like the performance of the switch case statement stuff, but I like to organize my code in the object-oriented way for my game entities because I want all of the player stuff together, I'm kind of out of luck. Like I can't have it both ways very easily. I mean, there are ways you could do it that would up your maintenance burden. You could say like, I'm going to put all the player functions together here, and then the switches that are like switch on the kind and then draw. And if it's a player, then call the player function. That means now for each object, in addition to or writing all the functions, you're going to go and maintain all the couplings everywhere. Yeah. So the point is there's a lack of flexibility either way you do it. With symbol sets, you are now actually free to do it both ways simultaneously. You can't actually get both simultaneously for any particular instance, but I can have my player stuff all go together for the player, but then I can say for these collection of entities over here, I'm going to put all of the, like, I'm going to have 5 different, I'm going to think of some like random thing. Say you've got an RPG, so you got a goblin, but you're going to actually have 5 variations of the goblin throughout the game. And so you're like, you know what, I'm going to put all the 5 goblin draw steps together because they're kind of all clones of the same one helper with variations. So I'm going to put them together, and then now you're able to kind of subgroup in free ways because you're able to plop down these like definitions anywhere at all, right? With the C scripting thing, I can now plop down any type of definition anywhere next to anything else. So that is the cool flexibility you get. It also, going back to the 4coder thing, big implications for how customization will work. So the hope is that I can start expressing how I want things to work at this level of, I'm defining a set of specific instances of a general idea, like all of the draw functions or whatever. I think it's a bad example actually, but I'm not really quite sure how to build a more practical example. It's very abstract, why it's so good, without getting more into the details of a specific example. But yeah, I think that's the vision, is that eventually a higher level data structure is going to have capabilities. Like if we're off of text files, we're going to be able to say things like, okay, I want to look through all of the code that I've got and comprehend all of it. So step 1, comprehension is built in from day 1. All the code that I've got available to this project right now, throughout all of it, find all of my entity draws and make a list of them. And I want to actually put that side by side with something about the drawing engine on the right, and then sort something out. Then tomorrow I can say put everything about the player entity together on a list on the left, and put that in comparison to something else, right? And the draw for the player can show up in both of those lists on day 1 and day 2, and so it can be next to different things. Like that sort of stuff is what I want to see. I can't do that part. The editor side layout flexibility isn't available in text, but the semantics of programming that way is available through C scripting. That's the point.
Okay. Usually these type of things, in my mind, if I understood it correctly, would be in the sort of like engine layer.
Yeah.
And then you would have it separate like this, sort of scripting layer where you can kind of say like, hey, give me, if we continue with the game engine analogy, like, hey, give me all the, let's say this type of, let's say goblin or enemy or something, right? You build this into the language. How does this change your programming then?
Yeah. So that's exactly why I call it C scripting, right? Usually, if you look at like a game engine architecture problem, you're like, I kind of want, like if you look at like a roguelike or a card game engine, I don't know any specific example. I know a couple, but usually what you end up with is like, okay, all of the different types of little characters you're going to fight in this roguelike are going to be defined in some like JSON file or some made up text file format or something like that, right? There's going to be some way to just be like, okay, goblin, HP stat, shield stat, speed stat, whatever. And then special abilities get listed out, and those are list of names. There's some data structure that you define that you kind of hack together over time just to spec out all of your little characters. And then that's the scripting part, and that's the data that comes into the engine. The engine then does the work of giving everything, assigning an ID to everything, and giving you a way to pass that all through the system. What I'm creating with C scripting, I think, is pretty much the same. Like it's compatible with that vision, except that, you don't need a scripting language. So it means that I don't need to write a new parser every time I want one of these things. I don't need to fit it into an existing parser. I don't need to use a separate scripting language that I'm separately learning and maintaining bindings to. It basically means that, well, actually, let me tell you about the second prong, because I told you there were two prongs to C scripting. The other thing I explored, and it turns out that the reason this one comes second is because it turns out to be redundant to the first. The first actually is good enough to give you the second thing for free, but there's a while where this was the main thing. So that first one, it sounds like cool, but like it's a small improvement to life. The other piece that I found super helpful to add to C was executing stuff before main. So main is your entry point. That's where your program starts, but that's actually a lie. It's always been a lie. There's always been a real startup point that calls main. And that real startup point is what initializes stuff like malloc, right? That makes it so that the C runtime is ready to go. If you want to, you can cut that part out, and then you're the true entry point. But if you're just on the C runtime, there's a true entry point. It does some C runtime in it, and then it calls your main. During that init time, if you look at the relationship between C and C++, that's where C++ constructors also get done, right? C++ constructors for global variables have to run before main so that you can see the constructed versions of everything. So before your main can happen, all those global constructors run. And to enable that, and also to enable similar things in C that are not based on constructors, but have this need to be initialized before main, both Windows and Linux, at least those are the two I've looked at, have this feature that there's like a special data section that they've set up where they've put an array of function pointers. And that array of function pointers happens to be called before your main function. It's one of the things the CRT startup is doing. So it's like, this is actually where I stole the idea from. I was starting with this idea that when sometimes I write a library, and it's not a library, I shouldn't call it, it's like a layer. I write a layer, and this layer will want to initialize something about itself. Like it will want to say, before you start making API calls, set up these global variables. We have some static data, but it's like laid out in a convenient way at global scope. We want to lay it out in a performant way before at runtime. So you end up in weird cases. Also stuff to do with like if you're going to do DLLs, customization systems and stuff, where when we load this DLL in, we would like it to automatically grab some stuff from the core and initialize itself with it or something, right? How can you do that? Well, the easy way that I found was another non-standard extension that it has to be supported by any compiler that supports standard C and C++ because of this constructor problem, is you sometimes run stuff before main that's like auto init. And so I started by playing with that. And it turns out with auto init, you can do most of what I'm doing with the data section hacking, but that the data section hacking is the more like data oriented way, because you can do it either way, right? I can use auto init, and then with auto init, I could go and make each one of my macros that defines a new symbol is actually under the hood another run before main function that helps to initialize the comprehensible global structure, right? That's one way I could do it. But that's like a bunch of code runtime init computation cost. So the switch to C scripting by the data sections was to say, well, the way they're doing that is they make a data section and then they iterate it. Maybe what I want to do is do that too, but with my own stuff. So instead of piggybacking on run before main, I will switch to making data sections that I decide when they go. Like I decide, hey, it's time to iterate this data section and to initialize something about my engine from the data in it. And so it turns out that they're kind of equivalently powerful non-standard extensions. Each one could implement the other one. You could use, if you had one built in with a standard, you could make a standard implementation of the other one. But the one I prefer is the data sections one, because it comes with the data pre-baked into an array, which 90% of the time is what I'm going to do if I have to do it with runtime init code. So that part I think is actually more obvious to see why it's valuable. The ability to say this code actually is like a script in the sense that it has code, like if you look at a Lua code, for instance, or Python code, you can write code that defines functions that you can call later. And then in between those, you can write code that does work, like on globals and stuff. You can just do some init work. And so while those allow you to intermix it, C scripting doesn't let you intermix the global, like you can't write x equals 3, x plus equals 1 at global scope, because that's just not valid C. But what you can do is you can put that code inside of run before main, and it's pretty much just as good, right? Like that's what you want. You can't interleave it totally freely, but you can at least group it with the module it belongs with, rather than having to say like, lots of APIs that I see have this thing when they're written in C where there's like one thing you have to call that initializes the library, and then you have somewhere in your program like main, and then it's like initialize, like you're telling it to go initialize all the things that you've already included. So up at the top you have like pound include physics, pound include graphics, pound include audio, and then it's a main initialize physics, initialize audio, initialize graphics. And I'm just like, it's so much redundant initialization. This is what the auto initialization was useful for. And so like this is the payoff is like now it's more, it's a little closer to that flexibility of just like, hey, here's a library I want to use. If I'm already including it, it's run before main initializes itself. So including it actually does the whole job.
Nice. I will need a lot of time to process that, like the implications of it. Are there any videos available where you show off C scripting?
Not super recently. I did one. So I talked about like when I first just stumbled upon the data sections trick, and I started to feel like I was finding a way to make it work, because there were a couple of false starts. Like I've spent quite a long time trying to figure out how to make C feel more like a scripting language. And a few of the breakthroughs were like switching to arenas and Scratch arenas in particular, and like API design patterns that really work well for very rapidly putting together like complex data structures and stuff, so that you can very easily specify these sorts of things in procedural code. But it was still not enough. Like it still had this linking problem. Like it felt like over and over again I was running into this linking problem of I define my thing, but it's not linked into anything else, and so it doesn't do anything yet. And there's in C, whenever you define something, there's an additional step of going and referring to it from somewhere else to make it actually mean something. And so, like tracking down that, like the fact that I had a solution that meant I was like, it's time to share the idea, but it's not ready. Now, since then, I've been building this game engine. I've been iterating on it. I think that it's closer to ready. And so I'm hoping maybe over the next couple months, sometime soon, I will do a more polished version. But what's happening right now is if you wanted to check this stuff out, right now it's still in development stage. The way I've structured the Mr. Forth stuff is I do these research projects. The hope is to be able to help everybody with it. But I also want it to be something I can keep doing. So I do have this stage where stuff that's in development is behind the paywall. So you can go and see the video that I put out a few months back that describes the idea. and I read through a little code base. I put together a little repository, but that repository is not public yet. So the repository is like an example of how I set up C scripting and some notes about what is working and what needs to be figured out still. And I did a review of all of that in a video, which you can find on not my main channel, but on my stream archive channel. I can actually, after we're done talking, maybe I'll send you the links for the channels that are worth looking at for my stuff. But on my stream archive channel, you can find the one where I talked about, here's everything I've got on C scripting so far. The code isn't public yet, but it is in pretty good shape. So I want to do pretty soon now a new pass. I've been working on like 2 versions of it. There's the standalone version that's just C scripting, just the data section hacking stuff. And then there's and that's like the research version, like prepared for research. Here's everything I've learned about it. Here's how to, no other strings attached, just start using it yourself if you want. And then I have my base layer stuff. So one thing I spent some time on like back in 2022-ish, 2021, when I had started my YouTube channel more properly, in the sense like I was making edited content rather than just stream archives. I had this base layer, which is, for whatever reason, I don't know why this is, but it's like somehow I guess I invented that. A lot of people refer to me as the person who set up the base layer that they are now following. I think that's odd. I thought it was like something everybody already did, and I was just kind of showing my way to do it. But anyways, I have this idea that like the C language kind of sucks, so you need to build your own base layer that is like the stuff you would want in a modern C runtime that isn't there. And that you want to pick one of these base layers that you like and build all your stuff on top of it. Because if you look at a lot of C programs, like their source code, without this base layer, they end up in this weird state where there's like random utility helper headers and stuff all over the place. And you're just never quite sure what the rules are. Like, why is there some math in the math header, but some math is in the util header? Like, what happened? And so to fix that, I'm like, well, you know what it really is? It's just like there's all this stuff that is so basic that I assume that it should be available to everybody else always. Like in all my other layers, it should be there. That's the base layer. And so I just set that up, and my base layer is sort of where I put all my language hacking stuff to. So if I have non-standard C extensions that I'm trying to wrangle, it's wrangled by the base layer so that it's available to everybody else in my system. So I've been building C scripting into my base layer too. That's the one that's in good shape. So I have some work to do is the point. Like I've got my base layer C scripting has gotten to a good point because I've been building this game on top of it to test it out and push it. So the next few steps I need to do are to like refine that, be a little bit more. I need to set up like testing framework stuff so that I can actually verify that all of the edge cases have been discovered for GCC, Clang, and the Microsoft compiler, and maybe TCC. I haven't been super comprehensive about the testing yet. So like that's the next phase. I think it's functionally where it needs to be. So I'm gonna probably do a round of like testing sooner or later and verifying that I've actually got it in good shape, and then I'm going to like release the refined C scripting intro video, and that'll be closed source for a little while for the people who are like members, and then eventually open source for everybody. But you can learn, in principle, the idea I've pitched is 100% accessible to everybody already if you just embrace this non-standard extension for setting the data section, right? Like from there, that's the key idea. If you go build off of that, you get to where I'm at. The work of refining it that I've been doing is what I hope will help make it even more easy to adopt, so that you can. Actually, I want to pause and tell you about a different issue that comes up with this. Well, because it's non-standard, okay, something I am really concerned about is that if I embrace this fully and I make a cool game, and then I want to port that, like I want to ship it on a Switch or an Xbox or something, that maybe the compiler tool chains for those are going to hose me because they're not going to comply to, like, I'm using this like standard C, C++ stuff, but those might be different. And they might not like, even if the compiler supports it, the platforms might not like the data section hacking. So I feel like in addition to setting all of this sort of arcane, hacky C stuff up, I need some kind of escape path where if you build your stuff this way, there should be a fairly rote, reusable solution that says, okay, I see that you want to compile on a platform where you won't be able to build a data section. And in fact, even if you could, eventually that's not ideal for like a release build because there's a little bit of extra... There's some overhead to this, right? So like each data section requires a separate page granularity of allocation. So if you have 10 data sections that each contain 100 bytes, they're all going to take 4096 or 4K byte allocations just to arrange them into separate pages, even though they're all 100 bytes each. So you're wasting about a 4,000 bytes per symbol set that you set up this way with those particular numbers, right? So that's not great. And additionally, there's that extra init work of like parsing your own object file or your own executable structure to find these data sections. In theory, and I haven't done this part yet, but this is the other thing I want to do, is I think that it should be perfectly possible to say, instead of using the symbol set right in the program you ship, you use it during development to a certain point, and then there's a transition path where you still write the code the same way, but now you're going to actually build by saying, build once with the weird hack on my machine now where I know it works. But instead of running the program, I'm building it into a meta program that then generates all of the data tables and stuff anyways, so that I can compile it the old-fashioned way with no hacks, right? Then I can eliminate any amount of undefined behavior or weirdness that happens between platforms. That automation is probably important to have before I really push this, because I don't want to end up with people following my lead to program in this weird, wild, wacky way, and actually it hoses everyone's projects because I didn't finish vetting that part. So yeah, I want to be careful to release stuff when I know that I'm releasing good stuff. And I also want to get paid. That's why I'm doing it slowly and working on it. But yes, eventually I hope everyone will be able to check this out and verify if it works for them. And separately, there has been one person hanging out on, so I have a Mr. Forth Discord these days where I like have just like threads to discuss computer stuff with. It's mostly just like we are all a bunch of computer nerds who have far out ideas we want to talk about. And so I shared C scripting on stream. Someone on that membership grabbed the code that's available and started experimenting and building their own like examples of things you could do with C scripting that I hadn't played with yet. So the point is just to say, I do believe it is a perfectly learnable trick. Like it's actually quite fun to program with. The hard part is the amount of preprocessor like setup it takes to create one of these, right? I want to get that as small as possible, but it's probably like a 10-line block of code. Whenever you want to create a new one of these data sections, it's very easy to add the tag that says put it in this data section. But all the extra trappings that you need to like ensure that you're referencing these things at the right way at the right time. Ideally, you want them all to get small consecutive IDs. Like if you're going to have 20 of these cool command things you've built, if you want them to be in an array, then there's going to be IDs to indexing them. But those IDs aren't discovered until runtime, which means if you want to reference one of these, what do? There are solutions. It's all perfectly possible, but it's a little weird and hacky, and it's behind these macros. And so you have to copy paste a block of 10, like a 10-line block with all the macro set up to get one of these data sections working with all of the C scripting features, right? So it's not pretty, but I think it's learnable.
Nice. So what people who are interested in supporting the work, how can support your work? And when they join the membership, what do they get?
Yeah. Oh, cool. Yeah, there's a couple things. Actually, I kind of like just scattershot. Like I'm trying to figure out the best things I can provide that make it worth it, right? Like I know that I don't have a deliverable product necessarily, but I try my best to make it worth it. A little bit of it is like you support it because you think that what I'm doing is going to be worthwhile. So it's a little bit of an ask for an investment, but I do try my best. So the things that are available are, yes, there's the C scripting is a good example of something that is closed source right now that you get early access to. And so you get a few things like that. Like iterations on my main base layer are also closed source, but available to members. And you get, so my entire YouTube video collection there's an indexed version of it. So I don't know if you're familiar with like the Handmade Hero has like indexed videos. There's like a few different, I don't know who else is using it, but his screen name is Miblo. He's been a part of the Handmade community since the beginning, as far as I remember. And he does the service where you send him a video and he goes through and annotates it and then you can play them back in his special video player and like search through it by keywords and stuff. And he does a really good job at marking up all the things you want to find. So you can go, if you are one of my members, that helps me to pay for this indexing service. And then you can go and access all of my videos, but with a keyword search feature built in. So you can find like everything I've ever built about arenas or everything about the C scripting. It's all indexed and it's in there. Lately, I've been doing this new series of videos about the data structure, development, the data structure, languaging, like whatever it is you want to call it, what I'm building there. I've been doing that series with this structure that I do one or two drafts of a video that are just for members before a free version goes out. So they get some time with it to like engage with me and talk to me about it before I send it out to the rest of the world. Trying to think, what are other advantages to being a member that I'm forgetting? That might be most of the ones that are super relevant. I have a list of them. I don't think that I'm forgetting anything. One other big thing, which is I track the amount of money, whether you're a member or one of the other, there's like tiers. So you can be, if you want most of the stuff I'm talking about, you want the membership. Some people just want to be supporters, which is cheaper, and all that does is give you like access to my like closed devlogs, basically. Whatever tier you're on, I also track how much money you've spent, so that if I ever do something like sell a game or sell a product, every dollar that you've spent supporting me, I consider it a credit to your account that you can then use to purchase these things. So even if you like what I'm already providing, the additional benefit is all the money that you give me, you can use it again to actually buy stuff. So you're going to fund me to develop things. If I develop something worthwhile, you don't have to buy it again. You already bought it by helping me make it in the first place, is my philosophy, right? So that's the other perk. That doesn't pay out yet because I don't have anything for you to buy. But if I do, that's the promise, is that will pay off in that way.
Nice.
And the way you get that, the way you become a member is on mrforth.com/membership. There's the 3 tiers. I recommend the membership tier right now because most of the stuff that's available is there, unless you just want to support. There's a 3rd tier that's higher. In theory, I mean, I'd appreciate it if people want to pay me more money, but the idea was once I do ship some software, if I'm going to be doing tech support, the people on that tier will be the ones who get like immediate responses. I won't promise to do tech support for everything I've ever built for everybody in the world. But for that highest tier, you're saying like, I'm going to pay the good money, so I want individualized support for the stuff you're shipping. Right now, again, I'm not shipping anything, so whether or not that's worth it is up to other people to decide. But that's the thought behind it. Maybe it'll change someday. I'm still trying to figure that stuff out. But yes, mrforth.com/membership. That's where people can go to support this if they want to.
Awesome. Do you have social media?
Not a whole lot. Like, I'm not on Twitter. I'm on YouTube and Twitch, and then I'm on Discord sometimes. So I think those are the best places to find me. On YouTube, I'm Mr. Forth Programming, or you can find my YouTube video, like my stream archive channel is just Alan Webster, I think, or maybe it's just Mr. Forth Dimension. I have changed the name a couple times.
With T or S?
With a T.
Nice.
Yeah, I'm consistent, even though it's embarrassing. I was like, I got to stick with it. There was one other. Oh, the Twitch is also Mr. Fourth Dimension with the T. Yeah. I think that's pretty much my social media profile at this point.
Nice. Alan, thank you so much for joining me. There was lots of technical, interesting discussions here. Cool. I will need some time to process it. I'll need to rewatch our discussion. This is all really cool. Thank you so much.
Yeah, well, thanks for having me on.